Molecular geometry is the three-dimensional shape of molecules. Up till now, we've been drawing these molecules as if they were flat. When we draw a Lewis dot structure for methane, for example, we draw the carbon, the hydrogen, the hydrogen, 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 and there are the electrons. And it's flat. But that's not what it looks like in real life. So this is what molecular geometry is about what these things look like in real life. Now, the shapes of molecules follow a pattern. In order to determine a shape, we need to determine the pattern. In this pattern, we're going to call A the center atom. Okay? A, the center atom. Now, a molecule could have more than one center atom. A center atom is simply an atom with more than two things attached to it. Center atom is any atom with two or more atoms attached to it. So in my example here, carbon is the center atom. These hydrogens are not center atoms because they only have one thing attached to them. If I have a slightly more complicated molecule, like this, then there's two center atoms. There and there. Both carbons are center atoms, and there would be a shape around each carbon. Okay. Now, two other symbols in our pattern. One of them is X. Might be B in your book, but whatever. We're going to call it X. X is any atom directly attached to the center atom. So these H's here in my methane are all X. And that's all I've got here in this methane. So the pattern is A for this center atom carbon, and 1, 2, 3, 4 X's, so AX4. That's the pattern. If I go back to this more complicated molecule, you will notice this carbon has also four things directly attached to it. This H, this H, this H, and this C. Those are the four things directly attached to that carbon. So it is AX4 around that carbon. This carbon also has four things directly attached to it. 1, 2, 3, 4. Also AX4. So this molecule has an AX4 around this carbon and an AX4 around that carbon. Notice the ones here I've circled in red, these H's, they're not directly attached to this carbon over here. That's why they don't count in this carbon's pattern. Okay, now there's one other symbol. Suppose my molecule was ammonia, NH3. This is the Lewis dot for NH3. Now we've got nitrogen as my center atom. So there's the A. We've got 3 hydrogens directly attached to the center atom. Those are my X's, so AX3. But what we've also got is this lone pair, this non-bonding pair directly attached to the nitrogen. that's going to have a symbol of E. Okay? E is the non-bonding pair. Directly attached to the center atom. It has to be directly attached to the center atom. Notice it's pair, not individual. So NH3 has this pattern AX3E. And the E is very important because it's going to talk about shape. Let's look at this one. This is carbon tetrachloride. There's my carbon, 4 chlorines. This one is still AX4, just like the methane. All these lone pairs on the chlorine, they don't count as E's because they are not on the carbon. They're not on the center atom. So CCl4 has the same shape as CH4. That's what I mean about patterns. Each individual molecule doesn't have its own shape in that sense. They are patterns of shapes. We can group them. They have a behavior based on their shape. It's not about what the individual atoms are. Let's think about water. This is the Lewis dot for water. So let's think about what the pattern is. O is the center atom, that's A. I've got 2 H's directly attached. X2. Look at this, I've got 2 lone pairs here on the O. AX2E2. This is why I've always drawn it this way. It's bent. That's the name of that pattern. So when I ask you about molecular geometry, what you have to do is find this pattern. Then I will give you this list, and all you have to do is match the pattern to the list. So something like water, which is AX2E2, here it is, AX2E2. Oh, look, it's bent. You write down bent. And literally that's what that means. It's bent. It's that triangular shape that I always draw for that. The next time we're in class, we'll actually build models so you can see what some of these shapes are. But the names should be fairly self-explanatory. AX2 is linear. It is a line. The molecules are in a line. AX3 is triangular planar. Planar, flat, triangular. It's a triangle. It's a flat triangle. Tetrahedron is a 4-sided figure. AX2E is literally another bent. It's the line bent. And trigonal pyramid is basically a pyramid shape where the center atom is on the top and the other 3 come down. There are other shapes, but these are the ones we will be talking about.